Hi, my name is Murch-Shafer, and I'm an honors student double majoring in computer and electrical engineering. And this summer, I contracted my internship with Cargill, or more specifically, their branded feed department, which is ran out of their administrative office in Blair, Nebraska, which, on a side note, just happens to be where I grew up. So it's really cool to be able to see all of the cool things branded feed is doing in my hometown and, across, the Midwest. So my official job title while I was at Branded Feed was a business analyst engineering intern. So that's a few complicated words that describes a little bit of what I do, which is identifying business processes and different places where there isn't knowledge, there isn't data to optimize or to detect errors. And from that, working with my boss, who's a data scientist, to try and kind of identify some of those errors and optimizations, although that's more his side of things, as he has his degree in data science, and I just help with the data collection more so. But the ways that we were able to bring insight to these business processes, there's two main projects that I worked on this summer in order to do that. The first of which is hyperspectral imaging to look at some of the corn and different products that we bring in and out of our bioreactors. And then also adding some IoT or Internet of Things devices onto trailers, trucks, um, trains, and even barges in order to gather that data and also provide some computing solutions on the go that are going to be able to unlock and lock different pieces of our process depending on that data. So the first main project that I'll talk about is a hyperspectral imaging project that I worked on. So just a little bit of background about what the process is that we're optimizing or why we need to do this. Um, our one bioreactor in Blair that's right next to our administrative office brings in 330,000 bushels of corn every day. So each of those bushels of corn is 56 pounds, and that adds up to being about 18 million pounds of corn coming into our bioreactor every day. That's not just for the branded feed process, but there's several different companies and pieces of cargo that operate on that bioreactor. One of them is ethanol. Some are produce, high fructose corn syrup, those starches and sweeteners that are then, sold into food products all across the world. Um, but we bring in a lot of corn. So any way that we can optimize a process, reduce errors, means a whole lot of money, a whole lot of time saved if you're able to automate it, or those fractions of a percent are huge margins for us. So one of the main problems that we have when we bring this corn in, it comes in on trucks. And within these, truckloads of corn, there can be all sorts of um, potential hazards to our process and could be further optimized by doing a few different things. Some of these possible errors are foreign matter. There's every now and then there's some nuts and bolts that get into things and that can screw things up terribly. There can be all sorts of different types of damaged kernels, and there's actually a grading process that's associated with that. But the main problem for the branded feed, the piece of Cargill that I work for, that's working on this right now, is aflatoxins and mycotoxins, which is a type of mold that can be very dangerous if you feed it to certain types of animals of the feed that we produce. Um, and so one of the ways we approached this was using hyperspectral imaging, but even before that, we were using the cheapest digital camera we could, using some machine vision software in order to see if we could detect some of these corn grading things, the damaged kernels, foreign matter, and beyond that, it was a little bit more difficult, but aflatoxins and mycotoxins. What we found is with that digital camera, that very basic digital camera, we could do some basic things, but not as much as we needed to in order to bring the value that we wanted to bring. But we were able to take that a step further when some recent technology developments happened with hyperspectral imaging. And for those of you who haven't heard of hyperspectral imaging before, um, if you know of spectrometry, using the different wavelengths of light to identify the elements or compounds within a sample, um, it's almost like combining the light spectroscopy with an actual image. So you get different points of light spectroscopy over that entire image. So that's a really powerful thing. So if you look at the bottom right, it's a picture of a rat. Just, an example that was really easy to see that illustrated the point. You can see the different frequencies of light, um, which you can't with a normal camera. Um, and from that, using some machine vision software, we're able to get a spectral signature and find things about that image that you would not be able to, um, but with a human eye and autonomously with a different camera or just basic machine vision software. And beyond that, so able to detect some molds, aflatoxins, mycotoxins that are very dangerous to our process, so we're preventing errors. We didn't quite get to this summer, but we've seen papers that were able to measure the starch content and protein content, which are the two main pieces of the corn kernel that we utilize that have the biggest margins. And if we're able to redirect corn that has a few percentage differences, if something has 2% higher starch than this other batch of corn, if we send the right batch of corn to the right place in the plant, then we're able to get 2% better. It's not exactly 2% better because the process costs different money to put things through, but we end up having um, um, better percentages in different places. And so that's the optimization piece of the hyperspectral imaging. And on to kind of the other project I worked on mainly this summer was some IoT data collection devices. So right now, we are a logistics-based business for the most part. We deliver feed to our customers, drop it off, or we deliver feed from a barge to a truck, to a train, to a truck, to a barge, to go overseas and internationally, delivering some of this feed. And from that, we can optimize that system. That's a whole lot of different steps to go through that can be optimized, but we're limited on how we can optimize that with what data we have. So this IoT devices that are going to be on the barges, the trucks, the trains, allow us to take that information and utilize it to optimize it to prevent errors in order to make our business flow smoother and, it makes the entire process better and more efficient. So just some features of particularly what we worked on. This IoT data collection exists all over right now. It's really big, but some neat features that are unique to, I think, most places that are developing IoT devices. Um, we're putting them on a semi-truck trailer, but we're actually giving that trailer its own vehicle logic, its own business logic. So it we have a driver that tries to drop off feed at the wrong location, which has happened to us many times in the past. That can cost us a lot of money. So what we're doing is giving the trailer the chance to lock itself if it detects that it's in the wrong area. And we're doing that by a bunch of different methods. We have GPS, we have inertial measurement units, we have some different Bluetooth low energy beacons at the customer's location. We have lots of redundant methods because we need to make sure that we don't deliver feed to the wrong area in order to, ensure that we don't lose millions of dollars by delivering the wrong feed to the wrong place, because that happens with the scale that we work at. And additionally, like I've talked about, is that remote data gathering. One really powerful thing we're just getting to, we're building not directly related to the work that I was doing this summer, but a different piece of the team was working on developing this giant piece of software using these Garobi data models to optimize our plant, our delivery, and driver assignment. There's just a whole bunch of different moving parts. Um, and by using some of those different parts to optimize, if we have a truck or that leaves to deliver feed to a particular customer during a particular part of the day, um, we tend to have problems with, getting stuck in traffic, or just it's more efficient to send at the particular time of the day. And these devices, by notifying the position constantly through that entire journey, providing us that data gives us the option to optimize it and say, or give this data to data models that are able to say, this truck needs to leave at 10 a.m. instead of 2 p.m. because there's a potential problem here. And with everything being assigned dynamically, that tends to be a really difficult problem. So as much data as we can provide these data models, they're able to make better decisions. Um, And I mean, I've kind of talked about this, but there's the error detection piece. Um, we can't be delivering feed to the wrong location. And just the more data we can provide to our data models, the more efficient and the more waste we can reduce from the entire process. But everything that we're describing, we're bringing this data in, we're making these optimizations. You can kind of think of it as making an air traffic control. If the screen in the bottom right, you see all the planes moving in the different directions over different paths to make sure they don't collide, and they have all of that information right there. That's essentially what we're doing. We're creating these pages that will have um, all of the data from every moving piece displayed on this screen. Oh, excuse me, my nose. And that's what will allow us to do all of these powerful things with this data. And then one particular implementation we are looking at for some of these IoT data collection nodes on trailers specifically is having a 4-node system. So if you see the semi truck on each of the corners, there's a circle indicating a node that would each have their own redundant sensors and then communicate over something called the COM protocol, which is a very redundant protocol used in the automotive industry that we're working on developing, or developing with, I should say. But kind of the last piece here is from those main projects, how I've been able to take it and how it's going to impact my work in extracurriculars. And particularly the main extracurricular I'm involved with is the Aerospace Club. So kind of in order of importance, kind of not, the first, main thing that I think I've learned a lot through this internship is the development of these Internet of Things devices. For the Aerospace Club, we build high-altitude balloons and CubeSats that have very similar pieces of hardware, um, but it's that remote data collection and processing. The high-altitude balloons and CubeSats have a little bit more um, happening on a particular payload than the IoT devices, but it's the same type of idea. I'm learning how to develop these remote systems, balance power budgets, balance radio frequency budgets in order to make all these things happen. So it's been really beneficial. The second thing is machine learning. I've been able to a little bit of that, not as much this summer, which should help us in the Aerospace Club, and some of the data we're getting back is using machine learning programs to simulate things and to get better data back. With that, some of the work that I was doing with computer vision could be used in the Aerospace Club. We just need to find the particular niche that best fits some of the knowledge that we've learned there. Um, and the third one, refining processes. When working with everyone that I was, a lot of them are Six Sigma certified, Lean certified. Um, it's alphabet soup, all of the different types of optimization programs. I was able to be around them, see how they change things within the work they do, and change the processes to make it more optimized. And I think that's going to be really useful, being able to take some of the things I've learned from them and how they optimize processes back into the Aerospace Club and see if we can change anything around to better optimize, our college students' life, because we're always so busy. We can't, be taking more time or wasting time. If we can find some better way to optimize something, we need to do it to better use our busy schedule in life. And the fourth thing here for data analysis, there's some new tools that Cardio's been experimenting with. They're switching from some big corporate licenses to open source licenses. And the main example of that is NIME, which is an open source data analysis software that I was able to work a little bit with, not as much, but I work with my boss who can use it really, really well, and shows me some of the giant processes of analysis that he has made that have helped me learn the importance and the power of some of these things. And kind of the last thing, finishing off, I think this last thing that I've learned stretches beyond the Aerospace Club and is going to impact me in all measures of life, especially once I get to the real world, and that's technical communication. While I have this summer worked on a lot of technical things, a lot of research, probably about half of my time was just preparing that information into digestible forms for people of all different skill types, of different backgrounds, in order to convey the ideas to them to make the next steps in the process. Because these things that I worked on were relatively early in the process, and I wasn't working on a giant team. It's a lot of these things that I was working on, it was just me and maybe my boss was helping with some things. But being able to take these and just convince people, because you say one thing one way to one person with a particular background, and someone with a different background, if you say that same thing, they don't necessarily understand what you're saying. They don't see the value that you're saying. So especially in these big meetings, trying to find the happy medium to say things in the different ways so people are hearing what you mean for them to hear, and also kind of what they want you to hear, or what they want to hear from you, in order to convince them and show them that these things that are so very powerful in today's world for optimization and error detection should be put into place and should be, invested in for the future. But, this has been a great experience, and I'm glad I've been able to contract this internship for honors credit. So thanks for the experience. If you guys have any questions, please reach out to me. It's been super fun, working on the presentation, working at the internship. So thanks for the opportunity.